Good morning to one and all, and welcome to the day 2 of the Engineers Conclave 2025. Today we here have the technical session on agriculture, technologies of agriculture, followed by a high tea and the panel discussion. We begin with the technical session 4B on technologies of agriculture. At this point, I request Professor Shantanu Chaudhary, Vice President INAE and Coordinator of Team 2, to kindly introduce our session chair.
Welcome. Good morning. So this is the second day of the Engineers Conclave, and this first session is on agriculture-led technologies. This is being chaired by Dr. R.N. Sahu. He is a principal scientist in the Division of Agricultural Physics of ICAR, that is Indian Council for Agricultural Research. And he has been in this area working for more than 25 years, and his primary work has been in the area of hyperspectral remote sensing, UAV remote sensing, precision farming, and plant genomics. In fact, I know him for how many years? For more than, I think, 15 years, because of his work in the area of genomics and other things. And he has projects, major projects, where multiple involved, and he's also engaged in this translational work with startups as well. So he's possibly the most apt person to chair the session.
Thank you, sir. Very good morning to all of you. Thank you, the organizer, for giving me this opportunity to be here and understanding the kind of initiative of work what's going on. And I'm very happy to be the part of this session that's on cyber-physical system for agriculture. Each other.
Yeah, good morning, everyone. So I'll just tell you a story what has happened yesterday night related to agriculture. There's a cyclone happening right now, Cyclone Motha, and I was pulled up at 9:30 from the CM's office, and then they said like we have to quickly see what is the assessment, what is the damage assessment. Can you tell us? In the night 9:30 they are calling from the CM's office, and we were all online in a conference. His major concern was, is there any damage to the agriculture? Is there any damage to properties? Can we quickly assess? The major problem was there was a power outage, and they were not able to see anything in the real-time governance system. And we were all trying to see, and then he was asking us, particular to me, like, can I use the live satellite images? Can I see now what is happening? And I said, sir, that is not possible. We cannot do anything now. We have invited the Satellite Space Application Center people, Space Application Center people. Everybody gave in the same thing. So what we realized is how unprepared we were yesterday night when we wanted to look into things. how unprepared the situation was. Only the people who are on the ground was able to give some information. But what was given as a challenge to us as a TIH uh, is like, can we prepare for the next one? Can we kind of create something which can be used as a simulations? Yesterday I was talking to Lohani sir. The power of simulations is what is very important today. And I'll see if I can talk about something, how this technology, P&T, positioning, navigation, timing, is everything today. You talk anything, I think you have reached here because of using some of the maps, live maps to provide your location. You have navigated, you have timing. So P&T is everything, right from space to common man, and agriculture is not an exception over there. It is very important that how we can leverage such P&T technologies. And also one of the other technologies I think very familiar, you might be not knowing, you should be knowing, is which we learn from schooling days, is a geography course which we neglect usually. It's now called Geospatial Information Systems. Amazing technology, lot of changes. I'll see if I can make a justification for next 15-20 minutes how we can kind of see what can be done through this. So I'll just talk about, I don't know how much we can call it as a smart, whether we can become smart in near future, but the whole game is to become smart city, smart agriculture, all smart. But unless the technology gets completely infused into the ecosystem, which at a national mission of interdisciplinary cyber physical systems, 25 technology innovation hubs are trying to kind of work together to see how CPS can in fact improve our vision of Viksit Bharat in most of the activities what we do. So I think basically there are three major factors. Any technology you take per se is, I would like to say, like, there is a capturing technologies where we talk about how do we capture the data. Once we have the data, how do we process this data for extracting the useful information? And the third one is, how do we use this outcome? How do you visualize this outcome for decision making? So the overall, if you see, it's kind of what we are in an era. I think for some time is a due to the advancement of computing. Yesterday also there was a small name called quantum computing is going to take over. So overall, I think it has become a data-driven system now. Everything is about data. Data is all what we are trying to kind of understand. Uh, there's a mathematical models used to be a lot of emphasis even now, but the data-driven models have become more and more powerful with the kind of data what we collect. So these are the three things. I think the second most important component, yesterday we had a plenary lecture on AI. Now, AI is also becoming very powerful, and I'm very sure smart agriculture will also be kind of seeing a new era, having the AI integrated into this through CPS systems. Now, there are a couple of things what we need to kind of understand. There is definitely a challenge. Agriculture is not a very straightforward system. Otherwise, we could have been always in a very, positive side. We have a lot of challenges. One challenge what we face, everybody understands, is the climate change. And this, as a hydrologist, also I understand the rainfall, other characteristics are very heterogeneous, spatially very varying, temporally very varying, and more importantly, it's not about, if you see, it's mostly human centric, right? All what we are doing is a human centric. Wherever people settle, we would like to create an agricultural lands or resources or whatever we require. So that was also causing most of the problems are human induced problems. And these are also a challenging for us. Wherever there's a drought region, we want to cultivate it. So we started looking at new ways, new arena. So this is something which is very important for us. The climate change, as you can see, a lot of then depleting groundwater and soil properties. I think Sahu sir may understand that what is the importance of all these things, and most importantly, the demand what we are creating today across the country, and also the exports what we want to make it. So these are some of the key challenges what we have, and how can we transform this is through integration of the technology. What I'm going to present today is how powerful is the PNT, positioning, navigation, timing, and as well as the geospatial analytics. One of the important aspects I think we cannot neglect, and it will become integral part of us as a cyber physical system, is the sensors. Everywhere the sensors become very important, so this is a key area. And how do we integrate the sensors from space to ground to people is what is all about connecting this geospatial and PNT there. Now, if you look at the future, how do we kind of look into this? We would like to go more precise because I think yesterday also I was talking, listening to Lohani sir, where he was just talking about the spraying. We want to do very precise mapping. We don't know how to spray across the field all the pesticides and all, but targetly we should look into. So we need a precise information where the damage is going to happen, where is the crop stress, where is the water stress in the land. So this becomes very important. So we need a very high accurate information to do that. And the drones also, today the drone technology is evolving very fastly. And then it should not happen that we identified a tree which is supposed to be, sprayed with the pesticides, and then because there's an error, it goes and sprays to the other lands. So this is a common problem if we can address. So this is what we require. Prediction is another very important component. Today, as I said, yesterday night, we were all looking at the prediction of what is the path of the cyclone, where does it go. So if we precisely know, we can take any decision. It will be helpful for decision making. And the last is very subjective, but very important topic is the sustainability. I think all of us are trying to see how our country can contribute towards the sustainable development goals. And agriculture is one of the key aspects for the sustainable development goals, and we should all be focusing on to that. Now, I think if you talk about the government of India, every sector, there are a number of schemes have been launched, number of, I mean, like you name it, any sector, I think mostly related to sustainability. In fact, agriculture sector has a maximum number of amount of funding and support is been provided through various schemes. Now, in spite of that, we see that it is not been, effective. And there could be one reason is the kind of monitoring what we do. The precise observation is like, how do we kind of understand, like, for example, I was talking to insurance companies. Today, crop insurance is a big thing, but there's also a lot of issues with the farmers falsely claiming for the insurance. How do we kind of look into? So geospatial technologies and PNT technologies helps us a lot. Now, let me give a quick glimpse of what is PNT and what is Geo AI. Uh, in a nutshell, PNT is positioning, navigation, and timing. You need to know accurately where is your position. So we require like technologies which we use, global positioning system. We have Navic. How many of you know there's a Navic system in India? How many of you ever heard about Navic? Yeah, I'm very not surprised that many of you are not raising your hands. This is our own GNSS system, Global Navigation Satellite System. Unfortunately, it is for a wrong reason in the news now, but I see a big bright future for this, and to become very indigenous in PNT sector, our own Navic will be very helpful. Then the navigational aspects, everybody understands why it is important, but I'm going to show you how it is connected to our agriculture sector, the navigation component. I'm not talking about the logistics, what farmer faces to deliver the goods at the right time, right place. We are in touch with some of the farmers in Andhra Pradesh. Even if there is a 1 hour delay in supplying the mangoes to the Mumbai port, entire consignment is getting cancelled. So imagine the kind of timing they have to maintain accurately. So that is the kind of efforts is there. Second most important component is we kind of neglect it, but inherently part of our system is spatial understanding of the ecosystem, which is nothing but geospatial analytics. Very powerful tool today. Every company, big companies from Google to Amazon to everybody is kind of using this. And one of the companies in India which is very good is Map My India. You can look into that. So a lot of things can be done through geospatial intelligence. So Geo AI is becoming the next gen technology which we can use it for agriculture also. As I said, these are some of the key aspects of positioning, navigation, guidance, and all those things. Now, I just put some few integrations about what is majorly possible synergy with the smart agriculture. I'm not talking about uh, the biology side or the plant biology side. Here, more of a technology what we can use under cyber physical systems. Definitely the integration of PNT and GeoAI, which is like precisely knowing, predicting where is the crop stress by using like for example, we have this hyperspectral imagery, we have multispectral imagery to precisely find out where is which crop is getting damaged, and then using our PNT technologies, centimeter level accuracy, the robot or the drone goes there, flies, and then puts it. In fact, I was asked yesterday, why can't I fly a drone? So I said, at this wind, no drone will be able to sustain in this cyclone. But again, so there's a possibility of this integration, and it should be done, and it is done, but not at a level what people have been using. Then, as I said, one of the technologies which we should focus, IIT Madras is on IoT and sensors, and this is key component is everything is sensors, and we need to focus of integration of sensors. Today we talk about AI a lot, so AI integration is also important. Uh, this is more to understand, to predict the kind of crop yield we can have, the kind of climate we can look into this. And the last is nothing but I would definitely like to see in near future our own system NAVIC integrated. It is integrated to some way in the disaster management side, especially for the fisheries, but not really to the agri. I'll also talk about what is the problem with the NAVIC little later. But yes, so these are the few synergies what we have. Now, if you look at the some of the key applications I have just listed over here, which can integrate both GeoAI and the PNT sector, the first most important component for agriculture is to monitor the soil health, which is again to know whether the soil is suitable or not suitable. So satellite technology can help us and to precisely demarcate which of the areas are available to us. Then the scheduling becomes very important. When do we sow the seeds? So one of our faculties who work on scheduling problems. So there is a varying schedule depending on when the monsoon is onsetting, and then it all depends on the availability of the water. The other reason is the non-availability of the surface water, the misuse of surface, mismanagement of surface water is causing people to use the groundwater resources heavily. Again, there's not much regulations on the groundwater, and you can see there's a depletion of groundwater. And this again is a problem in the coastal cities because there's a seawater intrusion, and then it becomes completely saline, and then the ground becomes useless. So there's a lot of interconnected problems what we face if we do not not properly schedule it and then use the resources properly. Then the third most component is what actually many of the people are using nowadays is crop monitoring. So I can fly the drones, check the health of the crop. I would like to see where is the crop stress. Maybe Professor Lohani will be covering some of these aspects. But this is the technology. If you see the crop, I can clearly see which is the water stress component. I can identify through the kind of hyperspectral and multispectral cameras. Today, in fact, we can do all weather kind of scanning, not using the cameras at all. We can use microwave data and antenna. We have a couple of faculties who are working who would like to develop an all weather kind of observation. So we don't have to worry about rain, weather, and other things. We can still be able to do it. So that's the power of kind of using this remote sensing technologies. Then the last one is the most important is the weather prediction, because the major input to for all our crops is water, and water is water temperature, because everything is related to again the availability of the soil moisture, and this is another big area where agriculture is dependent on. Now, this is something I think this is a new world for us, not new for mechanical engineers. If someone is here, digital twins. I think most of you might, how many of you heard a word called digital twin before, right? Okay. So I think every one of you should get into this today. Digital twin of even your own human body, everything is coming up. So it's becoming a big science. This is an area which everybody is focusing on. And as a young engineers, I think whatever area you are, there will be a possibility of looking at as a digital twins, and this area is no exception for our uh, I think smart agriculture. If we can kind of use this technology, we should be able to kind of demarcate and look at very cleanly. So we can integrate it to various systems. We can simulate and check it. So this is something which is the next gen technology which is promoted through geospatial and geo AI thing. And the next is mostly, I think, the next major technology what we use today is the drone technology. We can integrate number of smart sensors. I think today we are looking at on the fly, how do I kind of identify and display at the same time instead of having a multiple passes of drones. It is not always possible, it's time consuming. So can I have onboard computation? So I heard a new word called, I don't know whether I'm pronouncing it correct or not, neuromorphological systems, which is a key word now where the world is moving, where we are trying to do all the computations on the fly, the way we are doing now interaction, everything is happening on the fly, that I'm deciding what to tell, what to talk. The same thing, they are bringing this technology to the satellite imagery, where we would not like to see entire image of a place, but precisely pick up an area and get extracted the data. Only that data is transferred to us. So this is something new area which is coming up. I have not put here, but this is something to be looked at. And so there are different technologies. I'm not going into the spectrum and tell you what is, but I'll tell you hyperspectral camera, very refined, very narrow bands in your EM visual band and all. We are seeing that data. So we'll be able to, we are not able to identify because we are only seeing the three RGB kind of thing. But flies can see in a different spectrum. So there are different people. So likewise, if we can divide the spectrum, we should be able to pick up those signatures which will help us to identify whether this crop is stressed or not. So that is something which is very important. Today, the problem is, I'll also discuss the problem is the computational uh, requirements to identify is becoming a challenge, which is now overcome a bit. It's time consuming, but we should see how we can do it during the flight itself. Because the major problem with the drones is the the flight time required for you to do. If you add more and more computations on the flight, then the power is less to us. So I think this is a common term what we have been hearing, whether it's a PNT or non-PNT. We have a kind of real-time monitoring and predictive intelligence. The most important component, I think we should be talking about how do we kind of have an AI integration to all these sensors. So real-time monitoring through the sensors, like soil moisture sensors, what we have, we should be, see the whole component of the agriculture to be kind of the yield to be improved is the right quantity of water is supplied, because there's an evaporation what is happening. We call it as evapotranspiration. So to substitute the ET, we need to keep supplying the water. And this soil moisture should be available always to the root zone. And that is how we should be keep on monitoring this through the sensors, so that immediately there's a supply of water given to the crops or plants and all those things. And this in turn will help us to create a good decision support system, so that people can take, or the decision makers can quickly take a call on that and then provide a good outcome from this. I'm going to skip this. As I said, one of the key components is water management. Okay, water is the key for the plants, and this water management, whatever we have, need to be scheduled, need to be optimized and integrated with various sensors. And these sensors are again looked into kind of a geospatial map. If you open today any satellite, I can give you some of these European, and in fact we are trying to develop at TIH now an open source tool, a dashboard where anybody in the country can use this free satellite imagery to look at what is the crop health. Currently we are trying to build that with in collaboration with ISRO. I'm not going to go much into the details of IoT sensors network in GIS. IoT used to be independent earlier, but if you add the GIS component, it becomes very powerful, because the component what we are looking at in agriculture terms is very spatially varying. It's not uniform across the space. So we need to kind of get into the spatial network. Four things what I would like to bring it very quickly under the PNT technologies. One is called soil moisture content. We as a TIH, we are working on something called, if you take your mobile phone, there's something called reflected signal, direct signal. So what we are trying to work is, can we predict what is the soil moisture by calculating the reflected signal from the GNSS? And we are using satellite EOS 4 of ISRO, and we are working very closely with the Space Application Center to develop something called uh, GNSS reflectometry. You can do a lot of things, but one of our focus is to predict the soil moisture across, so that we can, on a real-time basis, can tell the farmers what is the kind of soil moisture. Is just not for the let's say for the agriculture, but it can be used for many purposes. In fact, the flooding has a major role for the soil moisture. If the soil is completely saturated, the chances of flooding is much more with the lower rainfall also. So these are very important aspects, and we are using this PNT technology to find out indirectly what is the soil moisture content from this thing. Next most important component is, today we are becoming, yesterday I think the ex-chairman ISRO was also talking about the autonomous vehicle. Why not talk autonomous farm vehicles? Now today we are working with Trimble and seeing like how autonomous vehicles will be useful in farm management. So the machinery is becoming a big thing. So precisely the machinery has to do, so we use the PNT technologies in machinery guiding. Then the management zones, we need to demarcate these zones from different, whether it's suitable for agriculture or not. And then finally, the most important component is, how do we work on improving the yield? Yield is something which we are looking at. But this is not the only thing. Today, there is a lot of science is happening on the seed level also. There's a drought resistant seeds and all are coming up. So I would say that this, without talking about that, but the technology is going to definitely help about 10 to 15% of the benefit what we are trying to get it. But still, I'm telling there's other technology also can be used. I'll just quickly go through this NAVIC related information for the benefit of all of you who are hearing for the first time. We have our own constellation of, the navigation system, navigation using Indian constellation. So it was also called IRNSS earlier. So NAVIC was given by the Prime Minister as a name. And we have very unique alignment. So we have like a geostationary satellites, and then we have 4 satellites which are in a stationary orbit. Currently, there are only 3 satellites which are functional. To get accurate solution, we need at least 4 satellites. Unfortunately, because of the failure of the clocks on the satellite, we are not able to use it for the positioning. But still, they are functional. They can be used. There's an S-band is still available for us. S-band is used for the emergency services, for texting and other things country is using. But the future is very bright. We are in directly working with NAVIC team in the ISRO. They are going to soon launch another 3 satellites and upgrade it to the NAVIC 2.0. So we are hoping all your mobile phones by the next year end or by 2027 end, for surely will be having the NAVIC chip embedded into that. We'll be receiving the NAVIC signals for tracking. So this is something I just wanted to put it. And NAVIC is going to be integrated across, right from the defense to any of our vehicles. And we are also working closely something called Academia Network of NAVIC. What I do is, with the startups, we are giving this NAVIC. So they are putting in their vehicles, and they are going to give us the live data sets. So across country we are doing, and we are building this around 100 universities. So this is some example. I just thought like autonomous path navigation is very important in the field, and reduce the fatigue. Fatigue is something is where I don't know how many of you have gone to the farm. There are a number of times people have lost their life. Of course, the way they use it, but because also of a fatigue, there are a lot of accidents do happen. And this autonomous, I have seen this system how it works. It's so beautiful that you don't have to do anything. The operator is sitting off the vehicle and then just looking at the field, and then it will be able to completely plow the field and in fact put the seeds also. As I said, GNSS reflectometer is something there. We have already the tool for national level. You can all log into this and look at So this called GNSS reflectometry tool. You don't have to go in situ and all those things. You can just use your GNSS signal to find out what is our soil moisture. Very, very important. Of course, the only problem with this tool is it's a very coarse resolution. What we are looking at is a very field level resolution, which we are still working with ISRO to see how we can provide it to them. Another important aspect I think many of you not know, and then we should be using, and we are pushing it along. I'm working very hard to get into this CORS network. It's called Continuous Operating Reference Stations. Survey of India has put across the country thousands of stations. Today there are private companies who have put thousands of stations. These are ground stations which are available where you don't have to get the satellite signals, but very high accurate signals can be brought through this ground-based connections, because these are the bases which are already kept across the country. You can access to any one of them and use it. We are working with the drone companies, we are working with agriculture companies. So we at the TIH are trying to integrate CORS for various applications, especially one of the applications is for agriculture sector. And this helps us a lot in localizing the or improving the precise location using the CORS network. And there's a National Center for Geodesy over here. They're also having IGIS stations. So if anybody is interested, you should also visit in the those. So CORS can help us a lot. I mean, people don't see the value, but I think it's very important. The positional accuracy improves a lot. It goes less than a centimeter if we can precisely calibrate it. Precision is also good, and the network availability is 24/7. It's not like we have to wait for the satellite connections and all. At least 4 satellites are connected to us. So this helps us a lot if we are using this CORS network. I'll just close it with what we do at IIT Tirupati Technology Innovation Hub. We are on positioning and precision technologies. We work wide areas, right from atomic clocks to the GOI applications of to the agriculture and various sectors. So PNT and remote sensing is one of our key areas in both technology aspects, skilling aspects, startup aspects. And we have recently developed a lab called Geospatial Intelligence and Applications Laboratory to cater all the digital governance and public good platforms to be developed. These platforms are not even also developed by us. Any startup who has this, in fact, we are going to become one of the largest repositories of the tools developed in India. We don't want it to be replicated. We want it to have a library of all these tools so that there is a one-stop website for everything and people can benefit out of that. And agriculture is one of the key areas for us, and we are focusing a lot on that. Last slide. We are also working on agriculture sector on a national program. We have something called National Geospatial Policy in December 2022, which has a game-changing decision for us. Earlier, it was difficult to do mapping and other things as an open thing. Now we have this policy put up. Now recently, Finance Minister has also given a nod for National Geospatial Mission, where a lot of activities related to geospatial is going on. And one of the programs which has been done, how to kind of get the data. There's a lot of data has been collected by the departments, government agencies and all, but never have been used or seen the daylight. And Operation Dronagiri under GDPDC is one way to look at how we use this information to kind of develop useful products for the district administrations and all. So we have selected 5 districts across the country, 3 sectors: agriculture sector, logistics and infrastructure, skilling and livelihood. In agriculture sector, we have so many startups working in these areas. You can see most of them are related either to look at hyperlocal weather forecasting. So these are some of the startups who are directly linked to agriculture sector. And the good point about this is used by the administration to showcase what is the improvement, what we are able to get it. And I got a very positive results from Varanasi district, where we are able to show that the yield has increased about 10 to 15%. The accessibility to the farmers for the insurance has become, the time has reduced, I think about 40 to 50%. So a lot of improvements have happened, and this is ground reality now. And we are going into Operation Dronagiri 2 to extend it to either more districts to showcase the large scale impact of geospatial and PNT. or otherwise we are going to get into more areas of applications, but likely that we might extend it to many areas to showcase how agriculture is getting benefited across various climatic conditions. I think with this, is a very important future path forward should be like definitely to integrate the Geo AI systems and PNT into any of the projects. Then the next generation integration should be kind of a go compulsory to put into that. Empowerment of farmer. I do GIS for farmers courses where we tell farmers to what is the technology available to them, not teaching them the technology, but at least empowering them like what is available to them. So I have a unique program called GIS for Farmers where we try to tell them like how this technology can help them, but not tell them how to use them. So that is something which is very important. And we should look at a national scale. Pilot scales have been done across. Now it's time that we kind of do it at a national scale at a large area so that we kind of do heterogeneous studies in this framework. I'll just leave it here. I think this is my last slide, but it's very important that the convergence of ENT technologies with geospatial and cyber-physical system areas uh, creates an unprecedented authority to transform the Indian agriculture. Okay, so I think this is something very important that we kind of look at all together. And in this room, I think everybody can contribute in a way somewhere as a cyber physical systems, and we should kind of integrate it and work together to see how we can build India's next gen agriculture, smart agriculture, ecosystem in the country, and especially for what we have the dream of Viksit Bharat 2047. Thank you so much for your time.
Is a move towards developing climate resilient agriculture. On the other hand, in doing so, people are trying for.
Yeah.
So, people are trying for different kinds of GM crops, which are in many cases complete carcinogenic or all that. So, how do you really strike a balance between these two?
So as I said, there are two components over here. One is on the plant biology side. I'm not just talking about that because that's a different, even the genetically modified seeds or anything. So that's an area which I'm not going to get into, and I would say I'm not an expertise to talk on that side. What I feel is given an infrastructure where we would like to provide uh, crop stress free environment, how do we use the technologies, what is our focus. So I'm kind of restricting my answer towards that. I would say that both have to go hand in hand. How GM will impact, what will be its kind of outcomes, uh, there should be some synergy between that also, but I would still stick to that. What I'm going to talk is only towards the technology side, how it is going to benefit it. So, and I can clearly see that from our recent results that more we can benefit. In fact, the problem with India is also the use of the traditional approaches, what we have been doing. There's a lot of loss of water and all people don't understand, and a lot of exploitation of groundwater. And me being directly water resource management person, I know how the surface water resources have not been utilized to a large extent, so that we can reduce the groundwater resources and other resources. I would still feel like I would focus on developing technology which can save a lot of water and improve the crop yield, given that the crop is already sowed into the farmland. So that is the kind of thing. Yeah.
Secondarily, you talked about GNS electrometry. In navigation, we are taught that we don't only rely on one system like GPS. In drones, we have GPS along with INAE to calibrate the results. So for GNS reflectometry, what are the calibrative sensors or calibrative measures that we are?
So, okay, GNSS is a constellation of GPS. GPS is a brand which we use it commonly, but it's a US constellation. So GNSS, when I say, it's all like combination of different satellite constellations. Yes, one challenge, or I mean, what we are doing is we need to still do the ground truthing, where we are trying to calibrate across the country at various sensors, and then see how accurate is the GNSS is a secondary information and quick information what we can get it from there. So these are two different things. Okay, na? Yes.
Yeah. Area is covered by these satellites, and what is the percentage of automation happened in Indian agriculture? Like how much area is automated?
I would say negligible, almost nil. It is now just coming in, especially farm automation. But I think one of the areas picked up is drone. Drone has been extensively used now in many areas for at least spraying the pesticides and all. But the problem is not it's a precision agriculture. They've been spraying across the field irrespective of whether it is. Only thing is the human intervention is gone over there. This spraying is done. But this is evolving technology. It's still tested. Even I mean, it's easier to test the autonomous vehicles on the agriculture field than the autonomous vehicles on our road. Because I think Professor Lohani sir can explain better how heterogeneous is our traffic when compared to our field at least. So I think these are the areas we are still working. There are a few companies where we are trying to closely work like Mahindra, Tech Mahindra and others. So probably you're going to see a sea surge of changes as we keep on pushing these things and as the technology becomes more and more cheaper and indigenously. I think IIT Hyderabad is on the autonomous vehicles. So we are also closely kind of working to see whether we can work such systems developed. Very nil, I mean almost nil, I think. But the satellite technology is good. We have a large swath data. We can cover hundreds of kilometers. So very good. The only thing is the kind of the time which takes to come back. We do have geostationary, some of the satellites which we can still take the data sets. But satellite technology at a centimeter scale or you know like fine scale is again a challenge to get the data. But at a core scale, definitely we can get the data. Large swath.
Thank you, Dr. Roshan, for
Yes,
wonderful deliberations and interactions. In fact, I would answer some of those questions what is raised to. First question is GM crops, though it is not in the preview of this talk what's happening. We are talking more onto geospatial technologies. That itself is a big issue to talk about. I think recent issue was GM maize crops. There was import was going to happen, but we stopped everything because of GM. It has its own impact. But it is a really critical and very debatable issue for the GM. So we don't need to talk more on that because we are not experts on that. Maybe some people who are into transfer biotechnologies, they will be. And ICRA has its own norms and regulations for that purpose. So coming back to the reflectometry, it is the radiations which you receive from the GNSS satellites which has been used using some of those wavebands for the soil moisture and other approaches. It has nothing to do with your Kimball or any other. Third point is what you was talking technology penetration. You see many industries, you talk of Reliance, you talk of Mahindra and Mahindra, and many startups who are well established, they have been working with many commercial crops. You look at the coffee, you look at the tea, you look at the cotton, sugarcane, even if some of those plantation crops, how geospatially you can handle them with respect to their variability, with respect to growth, monitoring and management. So that's what the whole talk was about. And many industries, I think we have around 800 plus technology, the industries who are participating with us using all these technologies for agriculture. So if you look at exact the figure, how much is this technology's penetration, I think somebody has to do that kind of analysis, but it is there. In your mobile, you just draw a boundary within no time. Using Google Earth Engine, you can know where I'm standing, what is the soil status, what is the crop status, what I should do. So that kind of penetration has happened over the years. And this is what the precision technology is. So I think they have been working quite some time with the 39 industries under their center and the TIH, and all related to PNT. And you could see Drone Giri program, how nationally spread out. So thanks, Dr. Roshan, for a wonderful illuminating lecture. And maybe we can discuss further also on this. Yes. Now we come back to the, thank you so much. Now we come back to the next speaker, Professor Bharat Lohani. I think many of you must be knowing. He is known in the country as the man of a LiDAR. So that's what in just one word I can define the whole career. He has been working on the LiDAR and the different platforms and for different applications, irrespective. And he has established also two known industries, private limited with the IIT Kanpur, and also they have been working quite some time for different purpose. And as he was talking of, Roshan was talking about the data acquisitions, the kind of accuracy what you require, and also the digital twin. Similarly, how synthetic data can be generated using different simulations using LiDAR. That's what his field of specialization. And field of specialization with respect to agriculture is he is working on the LiDAR for carbon mapping, carbon stock, biomass estimations, particularly the forestry, where there are a lot of challenges when you fly a drone or anything, but airborne LiDAR can help us. So that's what and he, to his credit, he has a number of students and also a number of hats on his head with respect to the recognitions and awards. And Professor Lohani is going to talk about how LiDAR can be used, LiDAR-based precision spraying using for the orchard crops, which is really a difficult issue. So you could hear what is the technologies available for the data acquisition. Now you are going to understand how that technology can be used for the applications. Professor Lohani, please. Thank you.
All right, thank you very much for introducing me. And so, yeah, after this introduction, yeah, I'm professor here in IIT Kanpur. And actually, Dr. Roshan has already set the background for my talk. He talked about simulation, he talked about smart spray, intelligent spray, he talked about autonomous tractors, autonomous vehicles, he talked about simulation. So many of those things I'm going to touch in my talk. And over here you will notice that the different organizations who are involved in this particular project, and SIMDAS is a new startup from IIT Kanpur, and SIMDAS, as the name is, simulation or simulated data as a service. So within this SIMDAS, synthetic data is generated, and what is being done mainly, SIMDAS has developed an end-to-end platform, and using that end-to-end platform, the autonomous vehicles can be tested whether they will perform good, bad, or what. So that particular SIMDAS platform can do it. And the SIMDAS platform for the simulation can be also used to create simulated digital twins, say agriculture zones, agriculture area on an orchard. So this is what we have done. The Krishi Spray, and our partner in this particular work is AV Agritech. Krishi Spray is their brand name. So this particular work we will be doing with the help of them. Also for this work, I took funding from IDEA, ISI Kolkata, and also recently a funding has come from City Social. So I would like to acknowledge all of them. Now one more thing that I would like to say, Dr. Roshan's talk was covering all the aspects. I will now rather focus to a very particular domain, and I will give an example of real cyber physical system. And what we will see that we are developing this cyber physical system not only for the sake of development or writing a paper, writing a report, rather taking it to the market. So the product that we have developed out of it is going to the market in next 2-3 months. So that is what has been achieved in this. So let's talk about what it is all about. So this is what you know. Say traditionally the spray, because different kinds of sprays are required in case of the orchards, different kinds at different stages. So traditionally it used to be done by people, and in that case the people are exposed to those agrochemicals, which is not good, which is dangerous for their health. Also it is a very time consuming process. So in order to handle this, there is a new kind of spray which has come in the market in last a decade, I will say, internationally, and last 7-8 years in India also. This is a mechanical spray. What this mechanical spray does, you can see a tower and it has got the nozzles. As this entire thing is being pushed forward, it keeps spraying. Now there is a big problem also with this mechanical one. So what you notice here, this mechanical spray saves the driver, saves the person. At the same time, it expedites the spraying, isn't it? But at the same time, there is a big problem with that. It sprays indiscriminately. Whether spray is required, not required, it is just spraying. There are, one design is this, there is another design of this. So here also, what you notice that spray is being done indiscriminately. And because of that indiscriminate spray, there are wastages of the agrochemical. There is also extra pollution that we are adding to the soil, to the groundwater, isn't it? There is cost involved. All these things are involved. So we thought, well, why not to handle this problem? Why not to make these sprayers intelligent? And to make them intelligent, our system, basic system design is this. Because I work with LiDAR, so we thought, okay, fine, there is a tractor which is pulling this 1000 liter tank and it is spraying. So the spray system is same, the traditional one. But what we are doing, we are trying to make it smarter now. To make it smarter, we'll be using a LiDAR sensor here. And this LiDAR, as it fires the laser pulses while the entire thing is moving, we will be capturing the data of the trees around. And by capturing the data of the trees around, a compute over there will decide, okay, where is the tree, where there is no tree. And accordingly, this entire information will be communicated to the nozzles in the back end. And these nozzles will switch on only if there is a tree. If there is no tree, there is no canopy, the nozzle will not switch on. So that way, the spray will be a smart spray. So this is the flow diagram of the different components that we are using in this. Now, one aspect of this is, as we are spraying from the nozzles, each nozzle is covering a certain zone, as you notice over here. So, in our data processing from the LiDAR sensor, it should be possible for me to understand what is the density of the canopy in this particular zone. If the density of the canopy is more than a threshold, in that case, the nozzles will switch on and will spray. If the density is less than that, these nozzles will remain switched off. They will not spray. So that is the core idea with which we work. And then also in addition to this, we wanted to capture the information in the map form. For example, this, we wanted to capture the information where my sprayer is going, how much area it has sprayed, which all trees it has sprayed, how much consumption of the agrochemical has been there. All that entire information we wanted to capture here. So the algorithm design was very simple. And in this case, at the bottom, you will see we are using the SIMDAS simulation platform. Because in the beginning, we didn't have the data from the field. And it is always difficult to go to the field, collect the data. Rather, why not to simulate that data? So SIMDAS, our startup at IIT Kanpur, has as that sensor and scenario platform in which we can simulate orchards, in which we can simulate the movement of the tractor and the sprayer, in which we can simulate the LiDAR data generation. All these things can be generated. So here is one example. As the tractor is moving and all these trees are simulated trees, and also the data, LiDAR data that I'm showing you here is the simulated LiDAR data. So the algorithm, finally what it does, as we are moving here, it makes the zones across the trees, and within each zone, we will determine the density of the foliage there. So as per the density of the foliage, we will take a decision whether that particular zone is to be sprayed or not sprayed. So that is what we will be able to do it. Fine. So in this case, there are many steps actually from the concept to take it to the product level. There are many steps, and I will show you those steps, how the things progress. This is the POC. So in the case of the proof of concept, which we did at IIT Kanpur, we are doing first the testing of our algorithms. Okay, and you know, this is very interesting. In this case, what we are doing, we are using a Husky. Husky is a very small robot, and in the back of the Husky, instead of these sprayers, we kept the torch lights. And wherever there will be a tree, LiDAR will observe it and the torch will switch on. So in order to replicate it, you know, the first proof of concept will be done like that, and you will see that quick example of it. So you will see that, so LiDAR in the front is observing, and as it observes the tree, the torches will switch on. For example, here also LiDAR will observe the tree and the torches will switch on there only. So this thing proves that yes, our algorithm is working. But you know, taking this algorithm from this stage to the next stage is a difficult process. So what we did, now we have to take our algorithm, our control unit, to the actual physical system. So the physical system means the farmer's tank with the nozzles and the tractor. So we took it and we designed it and we experimented that. So this is the prototype number 1. So in this case, wherever you find there are some canopies, the nozzles will switch on. Again, the canopy will be there, so the nozzles will switch on here. Right place. So that is also again the prototype number 1 only. From the prototype number 1, we'll learn a lot about what yet to be done and all that stuff. So then we come for the final version number 1. In final version number 1, we wanted also the farmer or the person who is handling this instrument should have a control also on the spraying. For example, if the algorithm part fails, now the control should be manually. So manually one should be able to operate it. So we added some more things in that. So you will see here, now we are giving the farmer or the driver of the tractor an additional facility that he has a manual device, and by playing with the manual device, he can overrule the automatic algorithm if the automatic thing fails. And in this case, we had also then a mobile app ready with us. I will talk about this app. Also, we realized that we were using earlier the 2D LiDARs. So 2D LiDAR will capture the data in complete 360, and that was a lot of compute intensive. So we thought that why can't we also use, instead of 2D, just 1D LiDAR. So we had finally one more version, and in this version, so again in this case, you will see wherever the trees are, canopies are, that side of the nozzle is working. One thing in this case you will notice, because nozzles are on two sides, so far we are using only two solenoid valves, and we are controlling those two solenoid valves. So all these nozzles will switch on or switch off simultaneously. But what we can do, if we increase the number of the solenoid valves, individually each of this nozzle can be operated. That is also possible. So currently the system finally that we have developed, that's the diagram of the system, where we have our main control unit, we have the manual controller, we have also inbuilt the proximity sensor in order to know if the vehicle is taking a turn, the flow sensor to know how much consumption of the agrochemical has been there, we can monitor that. We can also have the sensor for the tank level. Also the LiDAR is connected to the this thing by the Ethernet, and then all these things. So the final system I will show you in a while. At the same time, one more thing which we observed when we are working in the field, that currently the way this spraying is done, there are many management challenges. What are those? For example, the coverage is uneven. Okay, so whether it is dense or sparse, currently the system doesn't know it, and a lot of manual guesswork is there. How much we have sprayed, what all we have done, because the quantification is not there. Then the owner of the farm, he doesn't have any idea what that person is doing in the field, because there in the field someone is driving the tractor, but the person who is the owner of the farm, he's sitting in his office, he doesn't have any control on that. So that was there. And as well as once the job has been done, lot of data can be generated. There was no analysis of that, which all crops have been sprayed by what liquid for how much. It is not that there. So for that reason, we have now created an app, and this app it solves all these problems. It will do proper job planning. It will do the mapping also, where the sensor is going and where it is capturing the data. It will do better control unit management. It will do also live monitoring. Live monitoring means as the sensor is working in the field, the device is working in the field, the owner in his office can see where the device is right now and how much it has covered. All that information will come to the owner, and as well as lot of analysis of the data that we have generated. So finally, this app is also now ready with us. So this is the final device, and I would like to tell you that 4 such devices are currently in trial. After multiple rounds of these, they are in trial in Maharashtra, and in coming 2 months, we will be able to sell this device in the market, and we are starting by building 100 such devices. One more thing is there, you will see here, plug and play. So the way we have designed the device is a plug and play, because there are many such systems which are available in the market. So they can take this plug and play device, put it in their system and make that system intelligent. So that is the core idea here. So the target users, yes, India is a big market for those things, and the market size which we estimated is around 100 CR, and there are large number of such devices which are already in the field, and they deserve to be made intelligent. Internationally also there is a market, because in international level there are some systems like that, but they are highly expensive because of the kind of the sensors which they use. They are very expensive. What we have done, we have realized the same job but with cheaper sensors, and also the algorithm and IPR is everything ours. What will be the impact of this? The impact of this will be saving in the chemical, 30 to around 50% save in the chemical, isn't it? This is a big plus for the farmers. Also, now the tractor doesn't have to go time and again to fill the liquid. So there will be also saving in the diesel. And finally, there will be environmental impact, which is very important. Otherwise, we are just spraying indiscriminately, whether required or not, we are spraying. So now in this case, the spray will be minimized. It will be done only where it is required. So once we are developing this technology in India, indigenous technology, so there will be saving in the forex. And finally, this particular work that we have done, which is going to the market, spawns in some other things. Now what we are doing the next, I will not take much time in that because time is always a constraint here. Very quickly I will tell you, so far we are doing spraying the canopies. Wherever there is a canopy, you are spraying it. But in the next level, we are doing, because there are some sprays which are done on the fruits, directed onto the fruits. So using what we have done so far, we have also worked in that. And in that case, we are using only camera, and we are capturing the image by camera. We are doing the deep learning in order to identify the fruits. we are doing the depth estimation models, any depth or depth anything kind of models, and from there we are getting the depth information. We are combining all of these, and we have finally developed the system very quickly. So this is an output of a model which was not pre-trained. Once the model is pre-trained, it is more accurately identifying the locations of the fruit. Then we are using the depth anything. But again, in the depth anything, there is a problem in estimation of the depth. So we developed the method by which we can correct the depth. Okay, so we have a calibration method. Using that, we can correct the depths. Now this is just quick. This is from our simulated data. So pomegranate orchard. If we do the segmentation for the fruit, that's the example. We do the depth anything. So that's the depth map for that area. And why the depth map is important in this case? As we are going on a lane which has the trees on both the sides. If I'm taking the image will have the trees on the image will have the image of the fruits on these trees as well as the row behind. And when we are spraying, we don't want to spray there. So we need to estimate where these trees are, where we need to spray, and this row we don't want to spray. So we want to do thresholding. So that's why the depth anything is being used. And here we are doing the thresholding, so that only those fruits which we segmented, which are in the nearby rows, are now seen by us. So these are the fruits. Now, finally on that, yes, we create a zonal map. If you project that entire thing onto a plane, wherever the fruits are, we create the zonal maps. And with this zonal map information, we know where to spray, where not to spray. And that entire thing is communicated to our algorithm, to the detector and all this combination. And finally, we create a table. This is what is being communicated. As you are moving, each and every nozzle would know when to spray and which area to spray. That nozzle will know it. So this part is still under development. I think to go to the market, it will take 7-8 months or even more than that, because this work is going on. But the previous one which I was talking about, in 2 months, our device will be sold in the market. And I think that is what our satisfaction is of this cyber physical example. Yeah, thank you very much.
Now it's open for discussion.
Of the tree by the side. So some of the pomegranates which are falling perpendicular to the line of sight, they are getting captured. What about the pomegranates that are parallel to the line of sight? And
yeah. So the way it works, if this is your truck or this is your tractor, and I have one camera here, I have got one camera here, and this entire thing is moving. So it is taking the image, taking the image, taking the image, taking the image. So the entire strip is being captured.
it's like a cone.
Yeah. So image is a perspective projection. So the fruits are captured in this. I move further, another image is being captured. So we combine the final map that I was showing you is an integration of this fruit map, this fruit map, this fruit map. That way we have all the fruits captured here.
Estimate the yield also in that case.
Yeah, it will help to estimate the yield, and actually that is the post data analysis. It will help to estimate the yield. Also, if at some stage some kind of diseases are coming, so the image will also help us to understand the disease level. Also, one thing that I have learned is actually better expert in that. Whenever we export the fruits from India to other places, they need the entire data of how many sprays were done, how much it was done, everything. So in this case, we are making a record of that also. So there are additional advantages of this.
The fruits you are targeting, what are the leaves and other things? Don't they create any problem issues?
If a fruit is very much covered by the leaf, yes, we'll not be able to see it. But now the other assumption is, for example, there is a fruit, the leaves are here. So in this case, this fruit will not be seen. But we are capturing the image from here. We are also capturing from here. We are capturing from here. Multiple places we are capturing the image.
The diseases in the leaves, I mean, disease which is reflected in the leaf or the stain somewhere.
Yeah. So I think that's once we are capturing the image, we are not capturing the image only of fruits. Rather, after capturing the image, we are segmenting the fruit. Because in this case, second case, the idea was to spray where the fruits are. But the leaves are also being captured. Now the same data, right now we are talking about RGB. Using this RGB, again an AI model can be written. which will start talking about the stress in the leaf also. Yeah.
We are capturing RGBD data because we are using leader.
Yeah.
So the RGBD depth is also there because
Yeah.
that's what is giving you the shape of the canopy.
Yeah. So in this second case, in the first case, we are using only LiDAR. The first part we captured, where the purpose was only moving of the canopy. Only LiDAR we are using. But in the second case, I'm not using LiDAR, I'm using only camera. So the depth we are generating from camera.
From geometry.
Yeah, from depth we are generating from the depth anything, those deep learning models.
I have a question. Yeah.
No, our purpose is to capture poetry. Of course, there will be some limitation that we can't capture the top canopy, isn't it? So I think the way the future will evolve, maybe we'll work on that. The future will be some part, the top will be done by drone for the larger trees. But the sides where the drone can't do, it will be done by a device like this.
Which are laying in the parallel of the side. You know, front and back. They are also captured by the drone feature.
Okay, no. See the way the fruits are there, the way the orchard is, I'm going on this lane, I'm capturing the data of these two. Next time I come in between that row of the tree. And now I'm capturing here. Next time I come here, I capture it. Isn't that is how the space is done? So in between the rows, there are spaces for tractor to move. That is how the orchards are. So all the trees, this tree will be done from this side as well as from this side.
So there is a challenge when fruits are covered with the leaf.
Yeah.
That fruit cannot be captured.
Yeah.
So that is one challenge. Second challenge remains is for to go for variable rate spray. Suppose the canopies are there, but there are different pests or diseases with respect to fruit or the plant itself, like Sir was asking. So how do I know where to spray, where not to spray?
Yeah.
So that is again a challenge, but that has to.
It has to be solved.
It has to. So for that purpose, maybe you need some kind of other sensors to see whether there is a pest or disease,
Yeah.
and there will be multiple stresses also
Yeah,
on the
multiple.
plant itself. Again, how to do that?
Yeah.
You have a huge tank, so you should have different spraying liquid so that it can spray. So these are all advanced technology, but
Yeah,
it's wonderful innovations.
Because right now we are using RGB,
Yeah.
and RGB image will have certain limitations. Possibly hyperspectral is becoming cheaper. Instead of RGB, we put a hyperspectral, and RGB is a very, very cheap camera, isn't it? And putting that together, once we have the hyperspectral, we have better handle on detecting the disease. So that's something for future.
Thank you, Professor.
Thank you.
For your wonderful. Now we move to the next speaker. Professor Kolal Mandal, who is a professor in IIT Kanpur here itself, with a large experience in the thermodynamics and kinetic of glass forming alloys. And over the years, he has received many recognitions, awards for his incredible achievements. And most of his core work is into advanced materials technologies, and which has a strong relevance with respect to agriculture domain. You know, most of the sensors what we develop, they are in the field when you go, the corrosion happens. So how to make it anti-corrosion? So that's what the talk he is going to give today. So his talk is going to be alternate natural agro issues management to counter the corrosion. Professor Mandal, please.
That's not changed.
Okay. Thank you very much, and I really thank Professor Akhtar. So one day he just called me saying that you have to say something on agricultural based research kind of stuff. I said that I don't do such kind of thing. Well, no, you have to come. Okay. I said that fine, let me try. And that's what I'm here. And I really appreciate INAE for inviting me. And I'll present some of our work, what we are doing for the villagers. Okay. In fact, not villagers, for myself, but that can be useful for villagers. And we are also associated with one small entity at IIT Kanpur. I'll show that website. If you wish, you can visit that particular segment. It's called Rosie Shiksha Kendra. It is initiated by the gracious funding by Mr. Ranjit Singh, who is our alumnus. Okay, so that particular segment only works with the villages, and that work involves education, online education. Second part is on pottery, on leather, as well as on solar drying of vegetables, fruits, and alternate products. So there also I'm involved. I involve myself in two aspects. One is potteries, and second one is vegetables drying by solar drying. Okay. Professor Sandeep Sangal is basically the coordinator of that particular segment, but I invite all of you to come and visit that. Now, this is about alternate natural agro-resource management to counter corrosion. So this is little off the topic, it's not about sensing anything. It's about realizing something. Okay. So we have seen for the last two lectures I was present, and then I saw fantastic work done. And so this is may not be that fantastic, but it might attract you, considering that some of the aspects many of us simply ignore. For example, in electrical engineering, we hardly take care of the contact loss due to corrosion. Okay. And in the solar cell industry, one of the major problems that is coming up is because of corrosion related problem, and that leads to breaking of contacts and the cell functioning is off. Okay. So that I'll talk about a little bit about corrosion, and then I'll talk about protection. And when we talk about protection, one of the aspects can make use of some of the waste generated in agricultural field, as well as some of the agricultural fruits or vegetables can be used to generate some of the aspects, some of the things which can protect corrosion to a great extent. For example, I think chana. I think everybody knows chana. Is that correct? Chickpea. I think chickpea is absolute common to everybody. Okay. But chickpea skin can be used for protecting metals from corrosion. Okay. Fish skin. Okay. Fish scale. I don't know how many of you know. Fish scale contains a lot of collagen. And that can be used. People are trying to make use of that particular fish skin for making bandage. Okay. But it has components which can actually protect corrosion, protect metals from corrosion. And then waste like manures. Okay. Manure can also be used. Okay. So we have started this work. We'll show some result. I'll not get into the fundamental aspects of it. I'll just showcase, make it a little popular talk rather than a scientific talk. So now let's start. So this particular slide, nowadays it's an age of sustainability, as if we haven't done sustainability before. Okay, so that's the problem. We have been doing sustainability, but this has come up in its new avatar, and people all talk about sustainability. Just like nanomaterials, in the materials field, even in for example, micro sized materials people term into thousands of nanometer. Okay, so this is another aspect people are doing, but this is important. We have been doing it, and villagers are the best people to do it. Okay, so society, environment. Can I have a pointer? Okay, okay. So then I can. Okay, okay, fine. Okay. So this environment, society, economics, we all talk about. We know everything about it. And on the tea shop, I think we know it better. And then we have this particular cycle. This is a vicious cycle. We want technology, we want progress, and that leads us to several other issues like waste generation. For example, one such waste generation is basically used of electronic gadgets. Okay, it's a big problem, big problem. So now you have pollution, you have waste generation, and also there is one more particular part. Our world is limited. We are all limited, but world is becoming more and more limited. So we have to do something so that we can get back things from the West. It's a kind of recycling. Okay, so that's what we start with this, and then everything leads to a sustainability. Okay, so now come to. So now the problem happens, I cannot change the, I have to exit from the laser pointer. Okay, so now you see the kind of nuisance we do see around us. Leather industry. You'll be surprised to note that 70 to 80% of raw leather goes to the waste. And where it goes to the landfill. It goes to the environment. It goes to the society. Cow mania, not a little, not a kind of, it's a very significant number, 1100 million metric tons of cow mania. Okay. Waste medicines. Then stubble burn. Dumping, throw away in riverbeds. So that's how the pictures, whenever we put it, we start feeling concerned. And then once we come back, and then we feel okay. It's fine. Now come to the problem. So manure misuse, what's the global concern? Dumping, then those landfills, what it leads to. See, cow manure, we think that this is a fantastic fertilizer. Of course, it's a fantastic fertilizer. But it also has some nuisance creation. Ammonia, this methane, those are the things which come out from manure. Okay, those go into the environment, and those are basically serious greenhouse effect gas. Okay, so that means you see the kind of ammonia, then also this powder generation, the particle generation, those are also there in the environment. Now you see air pollution, haze formation, global warming, soil acidification, heavy metal accumulation, all those kind of stuff, they are coming into our society. Now this is a map, this is a concern for us. For example, if you see the top part, the northern belt of India, which actually houses a very large amount of cattle, whether buffalo or cow, and subsequently you see a lot of NH3, ammonia emission. Then you have some kind of stuff. For example, India, if you see the total land in use, and still here you see the northern belt. Okay, and some of the aspects are projected here. You can just read through. Now this is ammonia, and ammonia, if you see this India, this is a serious dark red colored zone, which has a very high degree of ammonia ejection. Now coming to this, waste mishandling. How waste mishandling can cause pollution, air pollution, soil pollution, water pollution, human health impacts, all are there. Now, I'll link it with the corrosion. Okay, so because corrosion is a nuisance. I don't know how many of you know whether corrosion is a nuisance, because we don't care much. And for your information, corrosion cost is a staggering number. So if I consider GDP wise, Indian GDP, it's almost about 4 to 5. Nowadays, it's becoming 6% of Indian GDP. I think 2020, 2017, there is a particular organization called INAE, National Association for Corrosion, National Accreditation for Corrosion Engineers. So that particular segment calculated, it turned out to be around 6 lakh crore cost that we incur towards corrosion. And that to India, you know, corrosion audit is very poor. If you go to Japan, if you go to South Korea, those particular countries, they have fantastic corrosion audit, but we don't have. And in fact, if we consider corrosion, we always talk about the actual loss in terms of direct loss, material, okay, throw it away. But indirect loss is more dangerous than direct loss. For example, bridge fell down. You know, now the connectivity is lost between two ends of a river or something. So now you can think of the added cost to that. Okay, I'll showcase some of the corrosion accidents. There is a site called Corrosion Doctors. You can just look into that. Some of the accidents, we never felt that had happened because of corrosion. Okay. Now, what are the effects? Atmospheric pollutions. This sulfuric oxide, CO2 is missed out, but sulfuric oxide, CO2, so those are the two gases which are reasons for acid rain. In India, we have corrosion map. As per corrosion map, Delhi is considered to be category 3. Chennai is considered to be category 5. Okay. But I'm telling you, if you take any material to Delhi and in the Mukherjee Nagar area or some areas, you will see those category cannot be numbered, because you will have puncture in your car body in just 6 to 7 months time. New car body. So think about the degree of corrosion and think about us, because we are guinea pigs. Fine, we don't care. Okay, but the car we definitely care for, because we have to spend money. We don't have to, our value is limited, but car value is huge. Is that correct? But corrosion does lead to that. So these are the elements. In fact, let me tell you, solar cell damage, one of the reasons are basically acid rain. Okay, so if the solar cell, the back part, which is actually locking it, if that is not properly locked, water can seep in, and those acid things are going in, and it leads to corrosion of those contacts, thin line contacts, and solar cell goes off. Okay, so these are the things. And then we have all those chloride ions, relative humidity, radiation, amount of rain, temperature, global warming, all those things can lead to corrosion. So these pictures are very common. I don't have to showcase you. You just click corrosion, you Google it, you will see thousands of pictures like that. But I am concerned about this part. I don't know how many of you know that the Bhopal gas tragedy in 1984, one of the major reasons was corrosion of pipelines. Okay. Now, whether you know that this Piper Alpha disaster that happened due to corrosion, Titanic, one of the major reasons was corrosion. The Silver Bridge collapse is another huge accident. Okay, so I'm just giving some of the glimpses of it. Okay, but there are many. So we have to be concerned. It's not about 4 to 5% of the cost, because that's not important. But we have to concern about our structures, about our lives. Okay. So that's what the cost of corrosion comes. You know? So if you see cost of corrosion, in India it's almost about 5 to 7 GDP of India, and in US it's almost about $3 trillion US dollar. And if you see the cost of corrosion is associating all the factors: shutdown, loss of efficiency, human life, safety, all those factors. So now, while after looking at this thing, somebody should think that, okay, let us be a little concerned about corrosion. Now, how would we protect it? Let me tell you, nobody can prevent corrosion 100%. Okay, because corrosion is a natural phenomena. You know, in thermodynamics we had read, it was a very difficult subject. You know, I never understood it. I struggle to understand that. But you know, that thing as simple word has mentioned that the natural processes cannot be stopped. It can be controlled. It can be reduced. So that's what people do while controlling corrosion. They try to find corrosion protection methods. So the most common protection method, what do you think? Paint it. Okay. So that is there, coating. Okay. There are other stuff, plating, potential change. Potential change for electrical engineers, it is fantastic, you know, positive, negative terminal, you know. Still I confuse that what is anode, what is cathode, why it becomes positive terminal, why it is negative terminal when we talk about galvanic cell and electrolytic cell. You know, so that's a confusion always. But their electrical engineer can actually have their hand into that. Okay. Change of condition, corrosion inhibitors, design improvement. For your information, almost about 60 to 70% corrosion protection can be done, can be materialized if you change the design of your component. You don't have to change materials. There are costly materials. Okay. For example, sometimes the steel cost can be more than the silver price. Okay. For example, there is a steel called Murray steel. So that steel is extremely costly. There are stainless steels which are extremely costly. Okay, for example, there is a steel which is used in biomaterials, 316L. 316L is used as a biomaterial, all those operation tools, because it doesn't corrode. And sometimes people also put it as a kind of prosthetic replacement. Okay, so those are costly because you don't want those materials to get corroded inside your body. And the body fluid is extremely corrosive. You don't know. You just take little bit of iron ball and put it in your sputum. You see after 5 days, extremely corroding body. So actually we are carrying corrosion materials, corrosive materials. So now coming to the some of the factors what we can think of. Now coming to the villagers, what we can do. We can contribute into these corrosion inhibitors. Corrosion inhibitors, the advantage is it is used in few ppm level, but it can turn a mild steel into a stainless steel. Okay, mild steel corrodes heavily. Stainless steel has a very high corrosion resistance, but mild steel can be converted to stainless steel, and the cost of stainless steel is almost about 4 times the mild steel. Okay, so you can think of that even few ppm you can actually get to that level. So that's what we are thinking of these corrosion inhibitors. And there are inhibitors. For example, chromate, phosphate, molybdate, nitrate. Nitrate, for example, this nitrate is used in the concrete protection. Those are the inhibitors. Okay. So, but these are not healthy. These can get into, for example, chromate. If it goes into the solution and chromic CR6, little chemistry, so that CR6 is carcinogenic. So they are basically, some of them are very highly health damaging ions. Okay. So, okay, they can give very good corrosion resistance, but we have to think something, green corrosion inhibitor. So when comes green, we turn up into some of the aspects which can be generated from green products. So now we have synthetic, we have traditional environment, but they are harmful, but we have green corrosion inhibitor. For example, neem. Everybody knows. Tulsi, turmeric, rose, marigold. I don't know whether you know that the inside part of a green mango, that what we throw it, people have found inhibitors from out of it. That is called that white, what is that called? White seed part. You take it out, you snatch inhibitors out of it. And India is actually having a rich source of tropical plants and tropical fruits. One can think of getting very high degree of valuable things from that. And inhibitor business is extremely lucrative, because if somebody finds an inhibitor, that fellow would never tell you what is the composition. And that can earn huge amount of money. Nobody will tell you. For example, Dr. Fixit, you cannot find the composition. Okay, so they will come up with that. So we are coming up from here to there. And the green corrosion inhibitors, ionic liquids, surfactants, biopolymers, amino acids, drugs, medicines, rare earth elements, all those things, plants and parts of plants, pomegranate, anarka chilka, you can make use of and then get inhibitors out of it. Okay, so now what are the advantages? Renewable, non-toxic, environment-friendly, economically feasible. I'll come to that economic feasible part. You know, without any training, any one of you, you just come to my lab, after 1 hour, you will now come to know how to snatch those inhibitors out. Okay, though we have patented it, but you can easily get it. So now alternate renewable sources. What are the sources? Leather, feather, hair, skin, scales, oil, other waste, animal excreta, byproducts, husk, different other waste, seeds, peel, crop, dry leaves, bushes, even grass, green grass. All those things you can actually get to a renewable, non-toxic, environmentally, economically feasible inhibitors, all those chemicals, and you make use of it in few ppm level in water, electrolyte, even coating, you can get the corrosion protection. So that's what the topic is, the sustainable partnership, inhibition efficiency. We have to have a very high degree of corrosion protection, green sources, sustainable resources, circularity, renewability, all the sustainable arms are touched upon. Okay, so it's a kind of embracing a good thing in a better manner. Okay, so that's what we think of. So let me just skip this. There's a market plus, so you can actually, if I think I can leave this slide to all of you. You can just read through. Now, if you see the crop residue, I'm just coming few examples I'll show. Crop residue, farm animal, leather residue. In India, if you see, crop residue is huge amount, 55%, which is a huge amount, and it's a huge field in front of us. So we have to get treasure out of trash, and we did get some of the treasures, and it opens up a huge opportunity for us. Okay, of course, as an academician, we need papers, patents, and I do get that, but the major important factor is whether I'll take it back to the village. Okay, so that's the mentality I do have. Okay, so I think that's good part. So now coming to some of the examples. Chickpea waste is a skin. How much time I have? I think I'll be good to go. So now you see, this is the process which is given. No costly equipments. You need blenders, grinders at home you are using, and you make use of it. This is a maceration method. So that maceration method uses water, because water is the polar liquid. It can take out all those useful things. And what are those useful things? Phenolic compounds, tannins, sapomins. Those are the compounds, those are present in those things, this chickpea, rich amount. Okay, and then we just take it out, and that concentrate we use 2 to 3 ppm level, we get the effect. What are the effect? Don't go into that part. You know, sometimes we have to show this just to get the paper published. But the main thing is this part. If you see, I'm just showcasing pH2, extremely acidic. pH2 liquid, if you put it on your skin, it can burn. Okay, it's extremely acidic liquid. Then pH 7, water, what you are drinking, that is pH 7, and pH 12, all those concrete structures, 13 to 14 pH they maintain. Okay, so if you see the inhibition efficiency, it's coming around 85 to 96%. And now if you compare the blank, which doesn't have any inhibitor, and when you talk about the addition of this extract, CPE extract, corrosion protection extract, this extract gives you the corrosion rate. If this is in the terms of millimeter per year, this corrosion rate reduction is huge, almost 2 times. Okay, so that's what this chickpea can actually serve as a fantastic component. And how we get protection? It makes a layer out of it. It's a in situ coating it forms. Then we have to see that how it sustains. We have done this experiment for the 30 days, and every time we saw that fantastic corrosion protection. And remember, these value, if you look at, 304 is a stainless steel used in a common utensil or our wash machine. Those are basically 304. So it's a stainless steel. So that has corrosion rate almost similar to this. This is mild steel. The rebar steel, what you use, the rebar, which is extremely corrosion prone, but that gives you a fantastic corrosion protection because of that particular extract that we get from chickpea skins. So this is cow manure. You will be surprised that this manure can have fantastic source of all those saponins, tannins, all those organic components. Those, if we take them out, and of course there are ways to take them out. Okay, so once we take them out, we did see a fantastic corrosion protections. In fact, we could see that protection ability is almost about 96 to 98%. Remember, in the market, the inhibitors, those are available. Even if you get 80%, it's a fantastic inhibitor. Okay. So like that, even we have done all those efficiency calculations. I'm just going some of the aspects. For example, this particular cow manure inhibitor, that can be effective in steel, that can be effective in this AA2024. This is basically the Russian aircraft, all the body that is made of this particular material. This is 2000 series alloy, aluminum copper alloy. This is called duralumin alloy. All the Russian aircrafts are basically made out of this. So now everywhere, and even magnesium is extremely corrosion prone. Okay, so that's the problem with the magnesium, that though it has extremely high possibility to be used as a engine products, but because of it has a very high corrosion rate, people are little hesitant to use it. So feedstock, cow manure, then feedstock, what we feed to them. Again, if you see all those feedstocks, those are naturally abundant, and everyone can give you the protection ability of 90 to 95%. I'll come to one particular part, leather. Leather waste, puffing dust we got from one of the industries in Kanpur. And Kanpur, you know, when I came here, I asked somebody that what is famous about Kanpur. I heard a particular word called kalatmak juta milta hai. Okay, so first time I heard that particular word kalatmak is a artful, kalatmak. I know Hindi Fasi people, I think they can relate kalatmak. Okay, so from there we got it, and here also we saw even in the strong acidic media, we can get a very good protection to the mild steel. You know, in a leather plant, the major uses of metals are basically when they dry the leather after tanning, they stretch it on a iron grate. That iron gate grows off in just I think 15-20 days. So there, if you just spray it, it can give at least 2 months protection. Okay. So now let me just keep off since the time is up. This is another work what we have done from, this flower is very common. Can anybody tell me what is this flower? Sadabahar. Okay, there is one more name to that. Huh? Fantastic. But I take it as a Nayantara. Beautiful. So that's what, you have to give little poetic justice to that flower. Nayantara. Okay. No, Nayantara is Bengali, but in South we have a beautiful actress, Nayantara. Okay. So from Nayantara leaf, I don't know whether anybody knows it, Nayantara, the entire plant is medicinal. Every part of it is medicinal. Okay. So there also we got fantastic inhibitor. So let me just move to the, this is one work we have done, porous clay. And that porous clay, we thought that we'll use it for storing vegetables, because here the summertime, we do have a problem of vegetable loss because of the hot summer. So this, it's basically a kind of refrigerator kind of thing. We did see the temperature goes to around 7 degrees Celsius when the outside temperature is 40 degrees with our clay part, what we have designed. But we found another interesting aspect. These are the clay color. This color, if you see this color, this is a golden yellow, though it's not coming up there. this has a fantastic sound absorbing quality. So one can make use of a kind of tiles to make it soundproof. Okay, it's a low case product. So we have patented this. So this is the all the measurements, and it has a much better than brass even. Ceramic tile, if you see, almost a very good thing. So let me just go to this particular website. I would urge you to visit this. This is a contribution towards the villagers, and if you see some of the pictures, okay, so these are the pictures, you know. So we go to the grassroots level and we try to contribute. Rather, we feel proud that they accept us. It's not that we go to them. Okay, so thank you very much. Yes.
Interesting presentation, but if they're so good actually, why the society or industry is not rushing after it?
It will come. It will come.
It will come, but this knowledge must be known in some form. Maybe you have now scientifically validated.
एक मिनट थोड़ा बंद करता हूँ इसको. Okay, so yes, yes, sir.
Is it because people wanted to have economic benefit much quickly because the prices may not be that high when you implement it? Because I was hearing some comments like this, I think some other day, that some of these things are not caught up because economic benefit takes long time to come. Whereas, like allopathic versus homeopathic, there was a kind of debate I was hearing. They said, okay, even though homeopathic is effective, but people don't go for it. I mean, people who want to make a quick business out of it, maybe the doctors or the pharmaceutical companies. So, would there be similar link here also?
No, why I am saying, because nowadays things are changing slowly, because people try to do kind of ornamental research to some extent many a times. Of course, this is not ornamental research. Okay, people need to and at the same time, we do realize little late. For example, sustainability we realized after we got unsustainable. Okay, but still there is plenty of time available for us. Now, that's what my feel is, that it will come up, but we have to pursue a lot. You understand what I'm saying? Because when somebody hears that this is taken from fields or something, you do hesitate. अरे ये आईटी से नहीं आ रहा है, ये रास्ते से आ रहा है, ठीक नहीं होगा, है ना?
Thank you.
Yes.
This is regarding your coating, you mentioned sustainable coating. So how thick are these coatings? What kind of studies done
Okay.
on it?
So
How often you have to do it
okay.
again?
So what we have done, we have made those liquid medium containing those inhibitors. We took a plate, simple iron plate, we sprayed it onto it, and then left it outside. And another blank, without any spray. We saw that it actually got protected for 30 days. We exposed it, and I think we did it during rainy season, and it actually did have a lot of protections. So we are doing still those experiments to validate that yes, even with a simple spray it can work. Okay, so 30 days it worked, and then we have to see the students' future also. So we have to take it out, write down something, publish it.
There is one aspect. So for the actual application, so how good is the coding?
Coding is fantastic.
Multiple
Yes.
codings,
You
so
don't
that
need.
it can last for a long
Yes,
time.
you don't need, and this is very low cost solution. You just spray it, and it doesn't smell. For your information, it doesn't smell. Here we have kept it outside. It doesn't smell. See, cow manure, or for example, any inhibitor. You think that you just put that leaf into the solution and then leave it like that, it will smell. So you have to have those little procedures to make it a clear solution. And once your solution is made, you leave it. You can come to visit my lab and it will show you that it doesn't smell at all.
Thank you. It's really very wonderful innovations. We can see from able to do a lot of waste metals are there, and how to make it well, but waste well. So the size, learning some of that. So I think some of that has to go to the field and market, and public awareness is.
I'm trying because I have contacted some other industries. So industries.
I was thinking, how come this is cyber physical system, but it's both and well justified and wonderful stuff.
Thank you.
So much.
Thank
It's a great cyber physical.
Thank you. Thank you.
Great cyber physical. So to just conclude 30 seconds, we started with the three lectures, with the A, that is the acquisition, assessment, then action. So that's what we started with the solution. Talked about all the technologies which is available for the cyber physical system, taking it to the physical system. Followed by that, action is how efficient we can be with respect to input applications using multimodal sensing, RGB LiDAR, and the field robotics for the straight or for input applications. Wonderfully, Lohani has talked about. And third one is the green cyber physical system, what we are talking about, and how we can create the natural resources with corrosive material, anti-corrosive material, which is really very useful system. So let's give big hand to all the people from the organization. And I must thank to the organizer for again asking me for such a wonderful session, hearing and getting updated with the many technologies for tech. And now I would hand over mic to the organizing team for the next proceedings. Thank you.
Thank you, sir. We thank all our speakers for the enlightening and the engaging talk. We would now take this opportunity to felicitate the speakers. I request Dr. Sahu to kindly present a memento to Dr. Srivastav as a mark of appreciation.
Yeah.
Thank you, sir.
There's a flight to catch, so definitely inform.
I now request Dr. Sahu to kindly present a memento to Professor Lohani as a mark of appreciation. I now request Dr. Sahu to present a memento to Professor Mondal as a token of appreciation. Thank you, sir. We shall now begin with our panel discussion on theme 2. Panel discussion will be moderated by Professor Shantanu Chaudhary, Vice President INAE. The panelists for the panel discussion include Professor Jalil Akhtar, IIT Kanpur, Professor Subir Saha from IIT Delhi, Dr. Bhupesh Lad from IIT Indore, and Dr. Sahu from ICAR IARI. Professor Subir Saha shall be representing our session 2 chair, Professor Lakshmidhar Behra, and Professor Bhupesh Lad shall be representing our session chair, Dr. N.C. Moore. Over to you.
Wait for us. Any order. You can just stop. If you have a PowerPoint, you can have the PowerPoint. So this is fine or
Yeah.
there's a microphone.
It's there in the chair.
Getting. Good morning. So after what 1.5 years of deliberations, in this section of this technology conclave, where we were looking at cyber physical systems, different aspects of cyber physical systems. So we are meeting to the panel discussion with the session chairs with the objective of finalizing conclusions. Because conclusions should also have a kind of recommendations, which INAE is expected to take it forward to different agencies, including government agencies, so that the future initiatives in this area, both as a policy as well as a research trust, can be pursued. So this is the intent of this panel discussion, to really crystallize outcome and recommendations. So I think with this background, we may have this form. I would request each of the panelists to give his presentation for about 5 minutes, and we can come back and try to reach a conclusion. But the fact is, the moment I talked about policy, but the interesting part of it is that these policies decide everything finally. Even the young students, who will they in future and their career, also in many cases will be implied and implicated by the kind of policy outcome that the government decides to adopt. Thank you. Let us start with. If you want to use a set of slides, you can.
Yes, sir. Okay, so very good morning to all of you. So I was chairing a session on IoT and sensors, and in the session we had three talks. I just tried to give a brief idea about what's and depending upon the okay. So the first talk was here on there were three talks. First was on the RF harvesting, then the two were on the sensors. So if I try to briefly say the first talk,
basically, it was about that how can we use RF sensor networks so that we can energize, for example, IoT devices and sensor nodes. Um, and the idea was that we can go about this in a phased manner. There are challenges. So basically, I just give the idea. So RF harvesting means we try to use RF from the ambient. Like, you know, you have RF everywhere. You have the uh, your TV stations, you have the cellular network, you have Wi-Fi router. So RF is there 24/7. And the concept is that if we can use those RF and convert into DC, then we can energize low power sensor nodes. And this is a very new trend. For example, it can augment the solar renewable energy, it can augment the piezoelectric transducers, because and the good part is that as compared to solar energy, RF is everywhere 24/7. So you don't have to go for a weather condition, you don't have to go for the wind. That's one of the advantage, and that can come into what we call technology which is sustainable. So that, because you know, if you imagine that you have all these sensor nodes, even your mobile phone, I would say one step further, and if it can charge on its own without, you know, needing any battery, because most of the time if you see all these mobile phones, all these gadgets, their lifetime is limited by the battery. So if you can get away with the battery, the lifetime is maybe increased, and that's a very good, you know, opportunity, like for a country to go on, that how can we work on this technology to make it popular. Of course, there is a drawback. The drawback is that if you really want to use RF energy from the ambient, if you look at the mobile phone, for example, it is very low energy, minus 70, minus 80 dBm. And that's something where you cannot use it for the practical DC charging. So there we have the advantage that if we can work on efficient system, efficiency means we want to ensure that at very low RF energy can be converted into DC, and that DC should be enough to energize. Of course, it can give you sort of watts or something, but it can give you milliwatts, I mean, or microwatts usually. So we have checked in our lab, for example, even that if you have a LED battery, it can be charged using this. You know, if you have just take a mobile phone, take its Wi-Fi, and you put your thing, it will work. So that's something, one aspect where we can work on. Of course, the idea is that you have to optimize. You have to optimize the spacing. You have to optimize. So, for example, Professor Day also work that can you try to make some beamforming network, and can you routing something the way we do for repeater. That's something where we can work on. So the idea was that we should have a long-term continuity in this, and that will come in the idea of what we call, it can go to the technology which can be sustainable, but we have to customize it. To customize the technology, you have to customize the, you know, RF network, and network here it means the real hardware, because, you know, yesterday there was a lot of emphasis on the manufacturing, and this again coming in the sort of manufacturing, because we have to design, develop, fabricate, and test the hardware which can work in the real scenario. And that basically means, for example, we have to develop the antenna, the rectifier, make a bit of integrated module, and that integrated module can work in the real case scenario for most of the time. So this is our, takeaway message. And of course, we have to simplify the funding procedure and R&D capacity. So it's something and it's good if different teams can work together, because, you know, it's not only one thing which can, for example, someone can work on antenna, someone can work on the signal routing, someone can give you a signal, the model of the channels, because we know that where are the losses. So communication, energy, RF, antenna, everything can work together to conform to a form which can give you something which is sustainable and which can go in a long-term form. So this is the first type of, the first takeaway from the lecture. The second talk was given by Professor Agarwal, and it was related to biosensing. And he gave many examples. For example, you can also try to integrate AI with the sensor modules. And focus was mainly on the biomarkers and I mean the to detect the disease, for example, at the early stage. And also we can say that, for example, can we try to personalize this for different applications? Of course, the challenge here would be, one thing is what we call sensitivity. For example, if you want to detect any disease at an early stage, can we say that even like, for example, he's working on this nano sensor. That means can be working one or two molecules. Now that there are two challenges: how to extract the molecule, number one, and the thing that can one or two molecule of the disease or of the cell can give the complete information. That's again is something where we have to work on. And from the hardware part, it comes to physical. He gave a good example that he's trying to develop one surface enhanced Raman spectroscopy, because the idea is that with the enhanced Raman spectroscopy, one can work even with low quantity of, for example, one or two molecules. We don't work with the normal Raman spectroscopy. The challenge here is that the cost, because if you see the Raman spectroscopy, its hardware is not cheap. Of course, he was, and we should work on this. That can we make a customized dabba or model where it can go with a low cost device and it can work also in a real time. So there are the real challenges, because then in this case all the nanosensors and can be worked or can be made working for example cardiac monitoring, for food safety. And main thing is that we have to also find out biomarker, because one issue is here the sensitivity, or what we call false alarm rate. So can we, for example, say that if you design one sensor for a particular disease, how to ensure that that particular sensor will only work for that disease and not for other disease? For example, like if person is having two diseases, and if you have any false alarm rate, maybe that you only find out one disease and not the other one. So there's something where you can. Okay, so what I was saying, that in this case, if you try to design this nano sensor or biomarkers, one has to ensure that under what scenario they can work. The selectivity is very good, and it can work in any kind of thing. And lab on chip. The last point is again very important part, that if you really want to make it very practical, if you really want to make it what to call very popular device, it has to be a small portable device which can be used by any person, and that will take time, because if you see the typical Raman spectroscopy, it is very expensive. So we have to work on this, and that's something where one our recommendation is that we should try to, for example, make different teams together so that the whole technology can be developed in-house, indigenous, and the cost of the device can come down. So that's very important thing. And so what the takeaway thing, that we can use different technologies. And yeah, so he was, for example, using one of the technique to develop what we call the electronic or current and voltage. We should also explore that can we use some other technique, like for example high frequency, like the sensor used on the RF or antennas, which can work in a non-invasive way, and maybe which can they can give you what we call the better sensitivity. Because idea is that one technology maybe doesn't fit all. So if you can have different technologies which are working in different domains, and if they all can be combined, and if they all can give you a better picture, then that should be taken into consideration, because that will give you some better idea that which technology to use for which application. Because when it comes to bio application, as was also mentioned by him, and this is a general trend, that the challenge comes when you want to detect any disease at early stage. Then you don't have enough cells which are what we call the sick cells, or what even say for example cancer. So if you want to detect benign samples which are not yet malignant, that's a very challenging part, because in this case you have to have very high sensitivity so that like you can demarcate between the healthy and the benign tissues. So under these kind of scenario, it might help if we have different technologies and they can work, together to find out that is it really a correct idea or sort of false around it. For example, nowadays, if you see you are having X-rays and ultrasound, sometimes they both give the same information, but you use to verify if something really the case, or maybe it's not working in one case, it might work in other. So that's something where you have to work on. And the real-time testing again. So idea is that if you really want to make any technology to be viable in long term, it should be giving you data in real time. The way, for example, if you go to the, today if you go to X-ray, by digital X-ray, you can see on the screen. Now something like this should also be shown, or should also be, tested. And this should also be worked on, that can we try to work in this aspect. That is very important part. The last talk was again on sensors, but it was mainly focused on flexible sensors and especially for gas detection. So Professor Panda gave an idea that use usually polyethylene as the organic semiconductor, and this is again very good aspect to the point of view of sustainable future, that can we use the organic semiconductor. It will be cheap, it will be sustainable, and also you don't have to worry about the what we call the material cost. The only thing is that can we make it workable, or can we make it overall application oriented, which can go for a particular scenario. Now for gas sensing, like he has shown many examples that yes, it can detect many of the gases, but again here one thing which comes here, the selectivity. So for example, you can detect ammonia, you can detect methane, but the point is that is it possible that if you design a sensors to detect ammonia, it will only detect ammonia, or it can also detect, falsely detect methane and ammonia. So there's something, selectivity is important. And for this, again, so there are two aspects. On one thing is what it was selectivity, that you want to select only that particular thing which you want to achieve. And second thing, what we call sensitivity. That means we want to say that are we able to detect even a small quantity of gas, for example, which is cannot be even sensed using a normal human nose. And there, if you recall, this was the focus, that how closely we can mimic the actual human nose. Of course, we can totally mimic, but we can try to approximate, because in that case, and what we want, for example, if we already know that there is some gas you can smell, then it's of no use. We want that it should be done at such a level that even before human can sense, and that's the challenge, and that comes what we call the sensitivity. That can we try to ensure that even such a low level gas concentration, any dangerous gas, whether ammonia or methane, can be sensed before human human nose can sense and detect. Other challenge is that, of course, sometimes we want to use what we call remote monitoring. So imagine that you have a lab, you cannot be 24/7. So if you can have some kind of arrangement where you can install a device, of course, the aim was IoT and sensors. So this is a very good example that if you can try to integrate one IoT enabled sensor, then you should be able to monitor the that particular thing from a remote place, from anywhere in the world, say just by using one IP address. But then you have to what we call revolutionize, that you have to implement or integrate both the IoT component and the sensor hardware. Of course, now it's not difficult because you have already IoT sensors not available in the market, so you can just try to integrate. But that should be done so that like it can be done from a remote place, and that is something is the main theme also of this workshop. That can we try to combine the hardware and the software, which means the cyber systems like IoT is one of the examples. So that is a very relevant part, and one should try to work for every kind of sensors. And then also what you can see in the last slide, that one is trying to design artificial node, but something better than this, because then we should be able to sense which is beyond the human limitation, and also from the remote place. So these two things, and remote place will come under IoT, and this thing will come under the normal security issues. And finally, that he sent something more points, like we should try to develop IoT is not being done, but we have to work on this. So, and we should look into technology from both the sides, that how much, for example, how much knowledge we have, and then can we also push for more technology, because it has like to and fro. It's not only one way affair. And we can say how much requirement we need. Competence, of course, should be done at every level. And as I mentioned earlier, we should try to develop ecosystem where we can develop different kind of sensors. I mean, like whether it is what we call based on electronic, based on low frequency, high frequency, chemical sensor, electrical sensor. So all the things can be done from that perspective. And finally, if you visualize that we try to develop the instant system for this, and we try to use the general framework of this cyber thing. So we have to combine all the efforts where AI technology can be used with this sensor form, and this only can be done if you say you want to have feature which is, so at the end, if anyone works together, we will envision that we can see the future as the lead mark for energy sensing, including what we call the energy sensor, that we can try to make the different form of energy which can be used for energizer power devices, and also of course overall intelligent automation. I think this is something which I can miss. Thank you.
I think it's come. I think I request all the panelists to come over here. I think my sincere request is that please restrict your comments to key points, and maybe for not more than 2 minutes to start with. Yeah. So that we can have more discussions rather than presentations. So I think South is go ahead.
इसको कोई क्लोज कर Again, very good morning to all of you, and to a very focus point with respect to the derivations happened in the last session. It's how this geospatial technology can be used for the CPS, particularly for agriculture. For that purpose, we have found a new word called cyber agrophysical system. Quite some time now, but I don't know if you look at Google, nothing like that is available, but we take agricultural agrophysical system. So it's called CAPS, cyber agrophysical system. Under that, huge applications, you can look at all those technologies related to fish and agriculture, natural resource management, livestock, fishery, anything you want to. So this is what the physical system, this is what the sensor application. So in the past deliberation by Professor Richard was on that, how these technologies can be used to bring the fish from static flowing to harvest even consumer level, and also going from simply low-cost sensors from IoT to the satellite. Coming back to the second, so this is what the acquisitions data which can be done with the different sensors, multiple sensing, data analytics. Not only that, also he has covered about the digital twin, synthetic systems, how we can generate simulations. Again, you can use generative AI and data analytics. Coming back to the second part was more on application oriented, using
Just listen to the talk. We not summarize it.
Oh, then coming back to the The next point is how this, whatever the data acquisitions we have done, how best we can make it implementable with respect to bringing precision, bringing the variable data. And this is what the talk about Professor Roha, Professor Bharat Rohani, and how we can go for multimodal sensing and computer vision and go for the various input applications to reduce the input loss and also efficiency. And that's what the mission request stands for, optimization of whole system. So one of the technology what he was swaying is there's only one technology. Like this, we have many. How we are going to come up. Coming back to the third one, again, a lot of waste you are getting from it. There's a lot of waste. You must be knowing right now the pollution started in Delhi after Deepavali. People will blame on the residual burning and most of the northwest part of the country. So he was talking of the chickpea, and we can talk of any waste coming from agriculture. If it can be used as a anti-corrosion material, or some of those gadgets or sensors which can be used for the purpose. And yesterday also I was seeing there's a drone made out of cane weeds, cane grasses, low weight and highly anti-corrosive. So by aerospace department here itself. So conclusion is the huge applications coming back to the geospatial technology, but how best to make it a translational research to go to the penetration level. So this is what the large gap lies with. So how we can modify that with respect to adaptability and looking at the Indian ecosystem, how we can make Indianization. Second part, how we can make it Uberizations. And of course, we need to bring a transformation with respect to the other side, the stakeholder. It's not individual farmer who can take all these technologies. Rather, it is the farmer producer organization. That's what the big initiative government of India is taking, a cooperative way, contract farming way that all these technologies can be penetrated to. So there are many low-hanging fruits which we can look at, looking at those commercially available commercial crops, gas crops, and also looking at some of those industry, the crops which are more into related to industry. Looking back, okay, people will be very happy to take up this technology because huge loss happens if something goes wrong. So this is what the my initial points. Maybe later I can add on. Thank you, sir, so much.
Thank you. In session, another session on cyber physical system, we had 3 talks. The first one was on energy efficiency for cyber physical system. It's very, very important because how do we application we are moving for this cyber physical system. There we talk about computing memory kind of systems and devices. That is, I think, very, very important. Lots of he showed the promising result. That is, I think, an area where we need to go further. The technology still needs to go to the field, although that is something which is required. The other one was on navigation, and there again, I think what we discussed is like Indian perspective context, we need a customized approach where we instead of completely autonomous assisted technologies can be and driver assisted technology can be developed. The fundamental models are developed, but still we need to focus on the accuracy in the areas. The control environment they have already tested and it's working well, but in open area because of GPS accuracy, etc., there are limitations. Digital twin development is something that they mentioned is the next steps for the cities, and the vehicle probably will be required, and then the networking of these vehicles, the cities and the road will probably result into better outcomes. And the last talk we discussed about the application of CPS in production system, where we emphasize the importance and the need of integrating the MSMEs in the cyber physical system development, both for their own the MSMEs efficiency point of view, as well as helping large scale industries for for the development of CPPS at their end for the end product. So I think these are some of the points which can be taken out. In general, I think we need to have customized approach for Indian applications, Indian rules, Indian manufacturing environment, which will be very different from when we compare it with the Western world. I think it will be very different, and we need to have those kind of customized approach. This is what I now summarize the three talks.
Yeah, so I'll be talking about the session which Mr. Behra was supposed to summarize, but anyway, as the chair has given the responsibility. The first talk was by Subhajit Arjodani. He's at university here. He can tell more. He spoke about non-invasive brain stimulation for rehabilitation. He spoke about various the various methods, processes, what he has been doing the research, how to predict the cases in case you have the data. So take home message from his to me is the trust on this research to bring affordable tools to save lives. Next was by me. I spoke more only on IHFC at IIT Delhi. I have foundation for promoting. It is one of the 25 TIH technology hubs under NMICPS of BST. I spoke about various activities under the heading of research and development, startup, skill development, and international relationship building. So take home message for this is bring product from lab through appropriate awareness. Now, when I say appropriate awareness, I mean we faculty are very good doing research proof of concept. When it comes to commercialization, there is a big lack of understanding, so-called, the value of debt and etc. And then what to get the funding, how to go to the market, etc., etc. So in a way, how can we create a new generation of faculty and researchers for the days to come? The last one was by Dr. P.S. Gandhi from IIT Bombay. He spoke about compliant mechanism for robotics and automation. He spoke of various applications and products. One of them I remember is the micro universal testing machine. He gave the advantages of how to make jointless mechanisms or machines. So take home message for this is the design focus exploring complex mechanisms first because of the advantages of energy savings and less actuators required. At the end, I want to give a general recommendation for INAE. All these presentations made, can there be proceedings out of it? And what, not in a very classical way, because I don't think any speaker will give any article. Rather, all these presentations be dumped into ChatGPT kind of thing. Can it create the proceedings and that can be checked better by us before it goes to printing and sharing with us? It will be very valuable document. Thank you.
Thank you, Shubhi. I think there has to be some documentation of what we discussed and what are the recommendations were. Not only these group as well as other group and formalizing together. That should be a record of proceedings of these. I think I would just like to pose one question to the panelists. Let's see, we have seen in these presentations some sample of technologies which are being developed in the country in these areas. It is not an exhaustive set. There are lots of things which are there which have not been presented. Now the question is, since with your knowledge of what is happening and what we have seen here, what do you think should be the direction of the future development in these areas? So that it also would inspire, I see many young participants here, that may inspire young participants as well as may throw some light towards a direction in which Indian SMT should progress in these areas.
Yeah, thank you very much. So I would just try to give 2-3 points regarding the theme of the course and related to the sensors and technology. So first thing about the sensors. So as you know, now sensors are used. Now the question is that how can we make sensors which are compact. And I would say one more step, which can be using material which are sustainable, degradable material, organic materials, flexible and wearable. I think if we use these three tags together, flexible, wearable electronics, printed on using very atomic technology, and then we can use these sensors for medical application, agricultural applications, biomedical, for example, to detect what we call the different types of disease, even detect, for example, we also that we are working on, many groups are working, for example, how to detect alternate way of using like the cancer or using other kind of blood cells. Then agriculture, lot of application has shown, for example, like we made develop sensor to detect milk contamination. Amul came the other day and say, okay, we want to have some other technology because they are using this lactometer related. People are say it's not yet now fully foolproof because farmers are able to, I mean, somehow manipulate. So we have to use a triad form that we can use one of the good applications. Similarly, also in India, one challenge is like the food adulteration. Can we detect, for example, like there was example was shown for honey, for milk, for all kind of things. But it should be compact device, and then only you can go to the next device. And also it should be IoT enabled, that means you can detect data from all of this. And coming to energy part, energy harvesting. So there is a way to move forward that because if you see solar energy or even the wind energy, the cost is a factor. For example, like people say, if there is no incentive by the government, no, then just we have to look for a alternate form of technology which is economical and which can work in the long run without any subsidy from the government. I mean that's something we have to work on. And for this, many technologies have to merge together. One thing was also shown about the other harvesting. Maybe, for example, we have to combine. For example, you have a simple material which can combine like solar, RF, which are all together. And for this kind of thing, for example, one thing is the material. Can we develop nanomaterials which can try to give us more economy and also more, I mean, thing from the actual point of view. And then it's also one of the talks on sensors. So materials is also on the key step. Can we develop biomarkers or even bio materials which are sensitive to anything, and then we have to integrate. We have to integrate nanomaterials, electronics, IoT. I think that will be a real cyber system from that point of view. This is something like that.
To be very brief, a very generic way I can say it should be more of a demand driven, not the fund driven. The technologies today we have huge dearth of technologies available all around. And demand driven means the stakeholder oriented. The stakeholder is if whatever end of the agriculture, the session just finished. How did all these cyber physical technologies can be used for agriculture purpose? We should see. And who are your stakeholders? So we may categorize and accordingly we should put one. Second is we should look at the economics. If at all it has to be adapted, what is the economics and how much the bucket allows for the stakeholder to use it for. So that way it can be categorized. Another is the scalability. At what scale? The marginal holders we are almost. So how to scale to that level to see that some of those technologies which can take in an acre field, which can be taken in a large area. So this is what the third is. Every technology has its own lifespan, like everything. So we have to be sustainable with respect to technology and translation to the field level application. And most important remains is what we see outside. Of course, nowadays we are doing that. Public-private partnership. Every technology can be put into a business model to have a deep penetration, translations, and since both the Lakshmi and Saraswati are together, I think it's going to be certain. Thank you very much.
I would probably bring another angle here in a specific thing. to all the researchers, young students, I suggest if you want to really make an impact with the cyber-physical system, please visit the end users. That's something we miss. We keep on developing things which are, yes, important, but the application is a very different challenge. I'll give you a couple of examples. You know, many times we see infections happening in ICU. That's very important aspect. Many times we just doctors tell that no, we could not do anything. Patient died. Surgery went well, but then some infection occurred, and so you know many times this infection occurs because of the non-compliance of the procedures. You know, nurses sometimes don't clean their hand with sanitizer, etc. Now, when we discuss with many schemes, the simple problem came like, can we put a camera and monitor that of whether the compliance is there? It can reduce the infection, and also it can help in antimicrobial resistance kind of problem. So these things will come from the field only. So one day, one doctor mentioned from AIMS, I can tell you that what happened is the ICU's ventilator screen got stuck, software problem, and the nurses could not see the variation, the parameter. They were happy the way the patient is behaving, but it got stuck. You need a simple camera to monitor if something is not changing. And what happened to the patient, you can imagine. His condition got really bad. Something happened. So these kind of things are very important when you go to the field. When you go to the Prathamik Swasthya Kendra, you will find that every ASHA worker is writing the simple information in very different ways. It's not just the language, even if they write the numbers, they date, for example, 10/12 or 10/12, 25, something like this they write, and then if you want to apply a simple OCR technology, it becomes a challenge. So need to develop customized solution for India specific thing. Another thing is the India specific knowledge, that the ancient knowledge. Many doctors, in fact, from various hospitals are now thinking in that direction. For example, earlier days, the so-called where they used to just see your tongue and diagnose many things. Can we not take picture of that? Now we have a good now image processing technology, and can we collect such kind of data and give more sense to our ancient knowledge? Try to think, take certain riskier project, not the conventional approach. I think another important area. I'm just giving sample, but you will understand that there are many things which we are not still touching. For example, the heart rate just before the birth and after the birth, if you can measure. Also, you can link it with the analysis of the cry of the baby, which used to happen informally earlier days. But now you have all the tools available, technology available. Can we take those those data, collect those data, analyze? Then one of the very senior neurologists mentioned that it impacts the cognitive development of the child, but we don't have those analysis available. So when you go to the field, you will find many such important problems, some strong evidence that we need to prove with probably your scientific, all this CPS based research. So that's what my take for the student. Please look into the application, go to the field.
Okay, so from my side, there are two basic points. One is don't look at the product level only, because we as engineers try to resolve problems. Look at the system level. What do I mean? I'll illustrate with an example, which is through my UTAC experiences. There, like we have developed some improvement in a device which is used by the artisans of Tulsi Mala beads, which are used as the garlands for the devotees of ISKCON, right? So when we look at the product only, then after the product has been made and given it to the village, now who is going to repair it? If the DC motor, we used it and the DC motor has gone back, the brushes have been deteriorating. The one from the get the brasses, so it has to get from Delhi, and the people are not using it for next 3 months, right? This is one. Then after it has been made, then there is a certain demand of 200 pieces, right? We'll make it, right? And so the point that the PhD thesis is done in last 5-6 years, that okay, look at from the very beginning, who are the users, who are the manufacturers, who are the maintenance, entrepreneur. Finally, the business, right? It costs about 18,000 rupees, and they are not affording that amount. So, what is the new business model? So, we have used what is called the product service system concept. So, in nutshell, look at the system level, not the product. The second part, we are doing CPS, as the first panelist said, that how to, second panelist also said, then how to get the India-centric things, right? So in this case, this Tulsiwana thing is India-centric, but we have been exposed to all this so-called sophisticated knowledge. Can they be implemented? The answer is yes. So after doing all some synthesis of this Tulsiwana, finally we bumped down, we implemented a robotics technology, BLDC motors and the VFD. Right? That has increased the cost, and then when you realize the cost cannot be reduced further for the quality of this product, then we go to the new business model. Right? The second part is there are enough number of applications available. In fact, I am thinking of to implement IoT in this device of Tulsimala, so that how many hours this thing is not being utilized, how many bits are forming. I just have to put a small, SIM card there, and that's it. The data will be collected at my rate. So these are the two things I suggest: how to utilize CPS knowledge for our so-called rural or our problem. And the first one is basically look at the system level, not only product level.
I think if there are any questions from the audience, just 2 minutes, I think, because there is also, yeah.
First of all, it's a wonderful panel discussion. I would like to connect what Professor Akhtar and Professor Lad said right now. Coming from a metropolitan city and settling down in one of the remote villages in this country, I'm in perhaps a safest position to comment on the situation of particularly healthcare in our country, where very recently, one of our colleagues lost his father when he had a heart attack, and then we were rushing him to the hospital, and on the way he breathed his last. And 2 months after that, he said that I lost my father, I don't want to lose my mother, so I'm bidding goodbye to this student living. This is the situation, right? So settling down in a remote village, what I feel is that even that the entire country is now using artificial intelligence, machine learning, deep learning as a mantra. And we are also people like us are also putting a lot of emphasis thrust with respect to sensing, multimodal sensing, data analytics and all that. So why not we try to assimilate this huge body of knowledge and go for something like a doctor resilient healthcare? Maybe it's a very bold term to use, but can we really try to develop the healthcare which is doctor resilient, which may even ignore or perhaps try to develop in its own way, so that even if the doctors are not located at the patient and near the patient's premises or near the
Are you referring to telemedicine, remote?
Telemedicine was attempted by Apollo and many other places long back. But then that video.
Modern interfaces. The problem you are telling is absolutely a cyber physical system problem,
Yes.
actually. So from that context, in telemedicine, the doctor in the loop.
Yeah.
That's what, because the
But what has been proposed by Apollo and many others was doctor is there in a video conferencing mode, but that is also not always possible. That's what I'm saying. That can we go something beyond that?
it's a challenge. So yes.
That's a current challenge, of course. So that's what my suggestion and my request to the committee to take into consideration.
Thank you. I think I don't know. It's time-wise, we are very marginal. I think there are also other last question if there is any. So I don't think there is any other question. So let me just summarize. Broadly, what we have found is that there is a huge opportunity of using these different aspects of cyber-physical system to touch life of human being, which is very, very important. See, technology is not just for abstract demonstration of know-how or sophistication of technology, sophistication of knowledge. But what is important is that at the end of the day, technology should reach people, should improve their life. I think from that context, I think what has been placed and what has been stated, say for example, if we look at from energy harvesting, which actually is critically important for sustainability, to the sensors for point of care healthcare, which is actually referred to the kind of problem that was being referred earlier, to actually people-centric automation in agriculture. These are very, very critical for the Indian context. And more such examples have been given by both of the panelists in terms of how do you address the problems which are coming from the field itself. And many a times we ignore information. Today we have the ability to capture a variety of informations and we have the ability to get that insight. I think that is also important. So for example, we may ignore some observation as trivial, but those observations, actually what Lad was talking about is that cry of a newborn just before birth and just after birth, that itself can have information. We always know that happens, but have we tried analyzing it? So these are the questions. This is what is called a kind of inquisitive approach for innovation. That these questions really lead to innovations, and that's also part of the scientific culture, which actually can help all these things to grow. And what finally should be talked about is that a simple thing which may be looked at from a rural development or rural need point of view, but that does not mean it would not require the most sophisticated technique. In fact, that's what also seen in the case of leader-based these spray of insecticides in a very targeted way. So for all these contexts, I think the problems which are at the grassroots, they're the most challenging. So it's better to look for those problems than look at papers for solving the problem. This is particularly for the younger people who are looking for problems and they go forward. Thank you. I think it was a very entertaining and informative and exciting session for all of us. Thank you.
Discussion. Now we will honor the session chairs for their invaluable contribution. I request Professor Shantanu Chaudhary to kindly present a memento to Professor Jaleel Akhtar as a token of gratitude. Now I request Professor Shantanu Chaudhary to kindly present a memento to Professor Dr. Sahu as a token of appreciation. We would now request Professor Saha to kindly collect the memento on behalf of Professor Behra.
That's for Professor Behra. Thank you.
We thank Dr. Ladd for being a part of the panelist and sharing his thoughts with us. We thank Professor Shantanu Chaudhary for acting as the moderator of the session and graciously conducting it. We also request your kind presence for the valedictory session. With this, we conclude the panel discussion of theme 2. The IT has been delayed a bit, and thanks for bearing with us for that. The same has been arranged post this session in the VH lawn. Post the high tea, we have the lunch organized at 1 p.m. and the valedictory session will be held after the lunch. And we request all the participants to kindly proceed for the valedictory after the lunch. Right now. Thank you once again to all the speakers and session chairs, panelists, and most importantly, our audience. Wishing you all a fruitful day. Thank you.
So high tea is here, lunch is there.